Okay, reviewing Fermat's theorem, we know that if f has a local extrema, max or min, and the derivative at c exists, that implies that the derivative at c is equal to 0. So what is that really telling us? It's saying that if f has a local extrema at x equals c, then the derivative of f evaluated at that c will equal 0 as long as it exists. Okay, so c has a special name. It's a critical number. We're going to talk about that later. But I want to caution you about two things. Caution number one, and that is, if you know that f prime of c is equal to 0, that does not necessarily imply that f has an extreme value at x equals c. So don't make that mistake. That's not what's being said here. Here's an example. F of x equals x to the third power. Let's draw that sketch. We've been looking at that before earlier. Okay, there's our sketch of x to the third power. Now notice the derivative f prime of x is equal to 3x squared. And that implies if we evaluate that at 0, f prime of 0 is equal to 0. However, f has no max and no min at x equals 0. So that's a case where the derivative at c was equal to 0, but it didn't mean that there was an extreme value at that point. The other caution number 2, f prime of c, if it does not exist, that does not imply the extreme value does not exist. And here's an example of that. Let's consider the absolute value, V for victory graph. F of x equals the absolute value of x. So we graph the y and the x-axis and we graph f of x. So the absolute value of x, we know that f prime at 0, the derivative evaluated at x equals 0, does not exist. And why do we know that? Because the derivative on the left and the derivative on the right of 0 do not agree. And that means that it doesn't exist because the limits don't exist from the left and right. However, f does have a local and an absolute minimum value at x equals 0. So you see in this situation, the derivative didn't exist at c, but the extreme value did. So what was the point of these two examples? This demonstrates that we cannot always be guaranteed to find extreme values by simply setting f prime of x equal to 0 and solving for x. That's not going to be the end all to finding these extreme values. There's going to be more to it.